So when we're looking at 6.58, I don't really have symmetry. I can pretty much pick whichever corners, whatever makes sense to start the sketch with. If I wanted to get some of the base geometry, I could start on the top and extrude up. I could draw this front shape as well and notch out the. So there's not any really one thing that jumps out and says that's going to be best. So one thing of note, I know I'm going through these kind of quick. I want to give you a sense of the pace and workflow that you're going to need for the CSWA and eventually the CSWP, the associate and the professional level exams. That when you make those decisions, you're looking through the test and you identify critical dimensions, things that are possibly going to change from question to question, and you make good decisions and be able to set that pace based on a 2 90-minute sessions or 180-minute 3-hour session. So when you pick your strategy, then you're going to have to stay with it and work through any of the issues. All right, so one of the things, the 0.625 5/8, 1 1/4 deep, assuming that's a drill point, we would have 118 degree conic in the bottom of the hole. It's not really called out flat bottom, so we have to make the assumption. If it's not something that's clear in these exercises, then you get to make the decision. On the exam, there should be enough information, or in the side view, hidden views, hidden line views, that you would be able to see that geometry. So we're going to start off, we are in inches, and we're making this cold rolled steel. And so I'm going to set a new part, and I'm going to start on the right plane this time. So we sketch, and I'm just making that lower front left corner at the origin, and roughing in the shape, and then we can set our dimensions. So width-wise, we are 2.24, so 2 inch 240. Height is actually not called out on that one, so let's hit the X, and since doesn't look like I'm going to use that one, Control Z. And one of the problems with Control Z is it might undo the one previous, so we do have to kind of watch that. So I'm going to go with the 45 degree angle. We have a height of 2 inches. And a width of 0.5. And then if I was interested to see, I could make this a driven dimension so that I can return that value of 0.26. All right, features, we're going to extrude boss base. I kind of like going back if I'm working on that front face, or the right plane in this case. And this is going to be 0.378. And again, a lot of this has to do with your perception. I'm kind of thinking the right plane will contain the hole. Any additional geometry that we need will probably be tied to that right plane. Right, and then let's go with the bottom. So if I select and go Control 6, I've kind of lost my frame of reference. So we would switch over to a hidden lines visible, so I can see that line at the 1/2 inch, which means that, given on where my right plane is, I should have a little rectangle and a little rectangle. Being able to manipulate that geometry and have that sense of where things are out of position is kind of critical. You'll develop that over time. So 760, and a width of 1 inch, a width of 1.14, and then our spacing, since I don't have a line there, I know from the way I drew this with the rectangles that there's a line there and there's a line there to pick. Since I don't have the lines from the rectangle, I'm going to go from vertical to vertical, and that will be my next best choice. So 1 inch, and so from the corner, and then the depth on the second one is 540. Alright, so those are going to get an extrude cut. Go through all and accept. Alright, so when I go back to isometric, I need to verify. Worst case is if I did not pick correctly, then I will break the relations and move these around to the proper corner. Alright, so using the profile, and really whichever one you're comfortable working in, you can stay with the hidden lines visible, and I added these. So we're going to go through this first group, and I'm going to do another customize for the work area and setting up our templates. So for right now, just utilize the pull down, and that is our display style. And I'm sketching on the back of the part. So we're going to make that continuous and the steps. We have a 30-degree angle, and I need a 0.74. So with the smart dimension, I pick the line, I go straight up, and that's going to give me my the width of the from the edge, and then 45 degrees because I have the non-parallel lines. Our depth is 0.74. Since I don't have, well, I probably could pick the line, but there again, it's what you see when you see it. So I saw the edge and the horizontal line. And then for our depth, we have 1.12. And because of the open profile, that 1 inch 120 is going to give us a the geometry to be continuous for open profile. If that line isn't there, it will give you an error that the feature can't complete. So we need one single profile, and then we can do through all. Need to check the directions, so the arrow is pointing up. If it's pointing this way, everything below goes away and we end up with a solid body and a solid body. And that's not the desired outcome. Alright, so Control 7 brings it back. With the 0.65 or 0.625 by 1 inch 250 deep, if we're going to make that a drill point, then we're going to need to use the hole wizard. So just like we did previously, if I draw the hole, it's going to cut back a certain distance, but it's going to be flat bottom. It's not going to have the drill tip in there. So let's select the face. I still like to pre-select. It knows where I'm placing that feature. And so when it goes into hole wizard, we're going to tell it that it's a simple hole. The types are counterbored, countersunk, countersink, a standard hole, tapped hole, tapered is a pipe tap, and then legacy is geometry from like before 2004, and we'll give you a lot of customizable geometry, but still able, pretty much mimicking everything that's in here. The counterboard slot and countersunk slot are from the last couple of versions, and the slot will also work in the hole wizard. Alright, so in Nancy inch, if we pick the different sizes and all drill sizes, so probably we'll stay with the all and scroll down. Alright, so we're stopping at 1 inch. So that being the case, now we're not going to be through all, so let's go ahead and set blind as our end condition. Give it 1 1/4. Oh, that one's new for, well, probably this version. Depth to shoulder, depth to tip. That's nice. Alright, so I'll take it. So if you're using 2019, I don't remember seeing that, so you're probably not going to get that one, in which case it defaults to the shoulder. Alright, so since I don't want to kind of overwrite, I want to overwrite dimensions very minimally, and so if we do the simple hole, simple drilled will include the depth. I can utilize that legacy, and we'll set the diameter of, oh, that was 0.625. I reversed my numbers. Anyway, let's go ahead and finish it out if I wanted to do that. And then this one's going to be to the shoulder, 1.25. And then that would set our geometry. If I go back up to top, since I swapped numbers there, and we come back to our fractional sizes. Well, let's filter that out to the fractions. Fractional drill sizes, we're looking at the decimals. If you don't see the decimals, there's a checkbox for that, show decimal values. So 0.625, 1 1/4 deep. And I was thinking 1 1/4 by 0.625, but all of a sudden that seems really big. Alright, and then we need to go over to positions to actually place it. And once I pick, then I'm going to it's going to go right into the point command, and wherever I put points, that's where it's going to place a hole. So you just want to be careful not to keep populating points that you probably don't need. Alright, so from the bottom, we're going to go from the point to the edge, 0.62, so 620 off of the edge, and 0.76. And then that gives us a fully defined sketch, and we hit OK. Alright, so now if I'm looking at this from the front and I go over those hidden lines visible, wireframe hidden lines visible, then I'm going to see that it adds the drill point, and that much volume is going to be, well, enough different in our mass properties that want to be able to take that into account. So I guess it's worth mentioning, since I did not set the cold rolled material, that our default goes to that of water, 1 gram per cubic centimeter. So if I edit the material, we go back to the cold rolled, I will set it with the 1020, apply, and back to the mass properties, and updates for the mass. Alright, so that concludes our 6.58. We'll save this and go on to the next one.